Welcome everybody. Today we're going to discuss in our What's New in Preventive Medicine series, detoxification, cleaning up your inner and outer environment. So we'll go into this in some depth, a little bit about toxicity in our environment, as well as the sort of predisposition that many of us have in our genetic structure that prevents us from being able to detoxify as well as we need to. So first we're going to review the basic principles like we always do. Functional medicine, or the new preventive medicine, we'll start by looking at what's old. The old medical paradigm, again, is treating symptoms and conditions, and you'll see why it's so important as we give some examples from today's talk, why just getting a diagnosis and treating a diagnosis doesn't really help us in many cases today. But basically, it was the old reductionist thinking. We chopped the body up into a lot of different pieces, and the problem that happened over the last 50 years is nobody was minding the big picture. And that's kind of where family practice comes in. And this is where the concept that Dr. Hyman introduces, that the doctor of the new era will be a super generalist, not a super specialist. We really need someone to back out and see how do all these systems work together. So when you look at the one disease, one drug model, the whole concept was, if you name it, you can tame it. If you find the right symptoms, then you say, oh my gosh, you've got bipolar, or oh my gosh, you've got diabetes. The problem is there can be dozens of causes of the same disease. So we end up treating the disease like it exists as a standalone entity, but it doesn't. And one of the things that we learned is there's a biology of the disease, the way that the disease functions in the body, and there's a biology of the individual that has to do with their attitude, their beliefs, their genetic predispositions, their will to overcome certain obstacles. So we end up treating the condition, not the person, and we're trying to get back to treating the person, not the condition, and we'll explain how that works. So this cartoon here is always one of my favorites. The patient sitting here, and you can see there's multiple people involved in the patient's care. Dr. Winslow will be checking your heart, Dr. Briggs will be checking your lungs, and I will be checking your bank account. Everybody's important. So what's the new medical paradigm? Treating causes, not conditions. Doesn't mean we ignore the symptoms or we ignore the condition. We use all the knowledge we have, but we try and find the underlying causes. So often, you know, somebody presents with heartburn, we throw them on a proton pump inhibitor or a Zantac or whatever. We'll say, well, what's causing it? Why are you getting that? It's a little more difficult. It takes a little more effort to treat, but it's important. So the functional medicine, the new paradigm, is based on an integration of all the different systems of the body, and I'll describe those 7 systems in a minute. But we don't treat the symptoms or the diagnosis, but the whole person. And you see here our guru at the top of the mountain gives us some great wisdom. He says, an ounce of prevention is worth a pound of insurance forms. And the forms seem to be getting worse, if you ask me. Now, why is it important to treat causes? We'll give you a recent example in the Accord study in the New England Journal in 2008. And the lesson here is that things aren't always as simple as they seem. We had 10,000 type 2 diabetics. Group 1 received intensive therapy to lower the blood sugar. The other group just received sort of regular standard therapy. Now, the patients who had their blood sugar lowered the most had a higher risk of death. Now, it just blew the researchers away. As you can imagine, they had to call off the study, and after 3.5 years it was stopped because we found that the aggressive blood sugar lowering led to more deaths and more heart attacks. So the question is why? How would that happen? Why would that happen? It's because elevated blood sugar is a symptom. So we're treating the symptom of the problem. It's not the cause of the problem. The cause of diabetes is either lack of insulin in type 1 or insulin resistance in type 2. So the treatment was doing nothing to treat the underlying cause, and the aggressive treatment very well may have carried some toxicity with it. So we'll learn now about how certain of these drugs can be actually more toxic than the undertreatment. So, you know, we don't know in this particular study if that was it, but toxicity of drugs can often be a cause. So you see the doctor examining the patient with the arrow through his head, and he says, offhand, I'd say you're suffering from an arrow through your head. But just to play it safe, I'm ordering a bunch of tests. And in today's medical malpractice environment, this happens more often than you think. So what are the foundational principles of functional medicine? This is my professor who I'm in the midst of my training with, Dr. Gant. He says this wonderful phrase, if you don't test, you've guessed. We do have the ability to test for so many of these things now at a deeper molecular level, so many conditions that traditional blood tests won't find the answer to. And then there's Dr. Hyman that speaks of this 10-tack theory. And he learned this from his mentor who taught him, listen, if somebody steps on a bunch of tacks, you don't just remove 2 or 3 of them and give them some aspirin and say, hey, this will take care of your pain. But so often that's what we do. We treat 1 or 2 symptoms. We try one little intervention, and we fail to go systematically after each of these different systems that I'll describe in a minute to find out, is there another tack in the system? And some of the case studies tonight will show you exactly how important that is. And then functional markers. This is something very important to understand, and I'll show you a kind of complex diagram in a second, but we look at functional markers because we can now measure certain molecules in the blood or the urine that tell us how well the body's working. So for example, if you have a B12 or B6 deficiency, your blood levels may be normal. So if you just check the blood, you may go, oh, I'm normal. I don't have a B6 or a B12 problem or a folic acid problem. But that's not accurate. We've found it's much more complicated than that. The body will try to maintain a normal, small little window of normal in the bloodstream at all costs. So the blood B vitamins may be normal, but inside the cell, inside the tissues where they matter, where they drive these important reactions that keep us healthy, they could be low. So how do we check that? We check what's called functional markers. We now know certain chemicals that will be elevated if your blood levels are low, or they'll be low if your blood levels are high, or some variant that we understand. So this is a kind of complex diagram, but I just want to show you here, homocysteine is something I measure in every one of you because we're aware of it. But what you see is that homocysteine is a functional marker for vitamin B12 up here and folic acid. In other words, if there's not enough B12 in the tissues or folic acid in the tissues, homocysteine will not convert into methionine, back into methionine, and it will become elevated in the bloodstream. So when we see an elevated homocysteine level, we know that there's probably a deficiency of vitamin B6, vitamin B12, or something we call betaine, trimethylglycine. These are things we use then to help lower your homocysteine level. So the homocysteine level, even though homocysteine itself can cause heart attacks and stroke, and it's a toxic intermediate molecule, we're not so much worried about your homocysteine level being high, but we're worried that it means that this very critical, what we call methylation reaction, which affects hundreds of systems in the body, is not working. Likewise, if the homocysteine is high, it may show that B6 is not available, because this reaction to convert homocysteine down all the way to glutathione, a major antioxidant in the body that we'll learn a lot about tonight, requires vitamin B6. So this is how we look at functional markers, and that's why checking traditional blood levels isn't always accurate and can be very misleading. And then one of my favorite principles to look at as we address these complicated issues comes from the Kabbalah, the Jewish mystical work. And there's this wonderful saying that said, God sends the cure before he sends the malady. And you're going to see tonight how well our system, even though we're exposed to toxins that are really relatively new in the last 100 years in our environment, heavy metals at a very high rate like mercury and lead and cadmium, our body has the wisdom to get rid of those in most cases. The people who get into trouble are people that don't have certain genetics. They've got genetic variations that prevent them from detoxifying well. Now, that being said, if we identify a genetic variant, we have ways to work around it. There are cures that we can use to bypass some of those defects. And this picture here is David the giant. Goliath the giant has just been felled by David's little slingshot and stone. And Goliath, being into functional medicine, says, David, I want you tested for steroids. So these are the systems. I call them the 7 hidden stresses. We could call it the 7 hidden systems. But this is the mnemonic, HIDDENS, hidden stress. The first one was our first 2 talks on hormone imbalance. That's one of the tacks, hormone imbalance. We need to balance out the hormones. Second tack in the foot, inflammation. Third tack in the foot, digestive disorders we talked about last month. Stress, gluten intolerance, food allergies, acid problems. Today we're going to talk about the 4th tack under the foot, detoxification problems. And then the other systems are energy problems, and that has to do with how well our mitochondria, which are the powerhouses in each cell. We have these little organelles called mitochondria, which are basically the battery. It gives the energy to the body. So the reason that's so important, just think of any neurodegenerative disorder. We're going to talk about Parkinson's today. Think of the loss of dopamine cells in the brain, which causes Parkinson. At a fundamental level, that's just the weak link. The problem is that some toxicity has caused damage to the mitochondria in that nerve cell, and it dies. It can no longer function. It's literally like the batteries in your flashlight going out, right? If the batteries in the cell go out, boom, it's gone. You lose enough batteries in enough cells, and your body doesn't function well. And that's the issue of mitochondropathies, and we'll discuss that next month. And then nutritional deficiencies like vitamins, minerals, neurotransmitters, and then finally the big, probably the one system that weaves itself into every other system more than anything is stress. Mental, emotional, psychological, spiritual, you name it, any kind of stress can basically act as a toxin to the body. So in fact, you see these 2 school administrators have tested every student in this school, and they're commiserating about the results. They say, listen, they've all tested positive for stress. And I think we would all we'd probably all pass the stress test too. I mean, you know which stress test I'm talking about, the one that says we have it. Okay, so what's it like living in a toxic world? We've got toxic thoughts. Remember how we discussed thoughts and feelings are chemical? So toxic thoughts, angry thoughts, hurtful thoughts, hateful thoughts, whatever undealt with emotional baggage we bring with us that we don't learn to process through good therapy, good growth, good self-control, whatever, creates a toxic effect on our body. Toxic foods, certainly. We now got genetically modified foods. We've got pesticides, herbicides. I see a lot of problem with this. Toxic bosses. My own nurse says she works for one. I can't believe it. But I'm sending her for help immediately. Toxic coworkers, neighbors. We all know what it's like. I mean, you have a bad neighbor. It's a pretty tough situation, create a lot of stress. That stuff eats at us, and we all kind of understand how it affects us on a real fundamental level. Toxic environments, chemicals, cleaners, solvents, mercury, gasoline additives, and toxic lifestyle, which would be sort of lack of exercise, lack of activity, any kind of lifestyle issue, eating disorders, anything that would cause toxicity. Let's look briefly at environmental toxins. 80,000 new chemicals have been introduced since the 1900s. The CD study, the National Health and Nutritional Examination Survey, examined human blood or urine levels and found that toxic residues were almost universally present in urine and blood. And by the way, urine and blood underestimate the load because toxins go into the body and then they go deep into the tissues, either the organs, the bones, the brain, the nerve cells. So they don't stay in the blood and urine that long. So when you've got urine and blood levels that are high, you know there's toxicity. This is very interesting to me. The EPA National Human Adipose Tissue Study, the NHATS, they evaluated toxins in fats that they took from cadavers and elective surgeries between 1970 and 1989, and 5 of the most toxic chemicals humans have created were found in 100% of the specimens, including dioxin, styrene. They're all names, but they're out there and they're in the environment, and if you're sensitive, they have an effect. We'll learn that not everybody's sensitive, so don't despair. Most of us have, the body has the ability to counteract most of these, but many of us don't. And then they also found that 91 to 98% of the samples had DDE, which is a breakdown product of DDT that's been banned since 1972. The point is, these things concentrate in the environment. It's very hard to get rid of them. Heavy metals, for example, really never go away. Mercury is pretty indestructible. I mean, it just moves from space to space, but when you get it, it's hard to get rid of these things. So what are toxins? A simple definition: anything that causes harmful effects to our body, mind, or spirit. And in the science of detoxification, we look at something called the total toxic load, which is what's most important. It's sort of the sum total of all toxins: pesticides, industrial chemicals, mercury and heavy metals, emotional and mental stress. There's even electromagnetic pollution now, infectious toxins, food allergies, sugar can act as a toxin, alcohol, recreational drugs. And I like this picture too because on the emotional, mental, mind-body level, it's very interesting. You see this door inside the guy's brain. That can be a source of toxicity, kind of what we open ourselves to and what we close ourselves to. So I love that metaphor of the door inside our head. We open ourselves up to certain beliefs that may create toxicity, or we close the door to certain, situations that may improve it, but we don't want to go there. We don't want to deal with that. We don't want to deal with past trauma, but sometimes we need to because it's the only way to cleanse it out and clear it out. So where do toxins come from? Environmentally, we already talked about heavy metals and all the organic solvents and formaldehydes, etc. We've got lifestyle toxins, which are drugs, either prescription or recreational, dietary substances, sugars, highly processed foods, caffeines. Tobacco and alcohol can act as toxins, obviously. Artificial food additives, colors, flavors, preservatives, the hormones in meat. So we've got this little girl here. She's probably, about 2, 3, talking to her little brother. And she says, look, between going to school, watching TV, and doing my homework, I hardly have any quality time to spend with my doll. I think we all understand that. Life's busy, and busyness itself can be toxic. Not always. So here's emotional toxicity. We've got this husband and wife fighting. We've got a therapist in the room, so she understands this very well. The woman says, if you were my husband, I'd poison your coffee. And the husband, of course, says, if you were my wife, I'd drink it. So we've got serious problems out there. I mean, there's toxicity everywhere. I mean, intestinal microbes. Remember last month we talked about how certain dairy products can form what we call gluteomorphins or caseomorphins that can act as toxic chemicals on the brain. Parasites and bacteria certainly create toxicity. And again, last month we went over all the digestive disorders that can create brain disorders. Metabolic reactions, if your body's not breaking down ammonia well, or different hormones, and we'll talk about that tonight, or even blood sugar imbalances can create toxicity. We'll just spend a second to show you that toxins can affect weight gain dramatically. There's a lot of studies here, I won't go into each of them, but toxicity, the more toxins in the body, the harder it is to lose weight. They jam up the biochemical pathways. They affect the ability of thyroid hormone to work. And the body has a sort of protectiveness. Some of the fat that we hold is a way to protect our body from toxins, which get stored in fat cells, so it sort of walls them off from affecting other important organs. So what happens? You start to lose weight, the fat releases the toxins, the body senses the toxicity, and it shuts down. It says, hey, don't lose any more weight, gain weight again, because these toxins are going to harm us. So that becomes important. Now this woman here is speaking to her doctor. She has a toxicity problem with heavy metals. She says, I have metal fillings in my teeth. My refrigerator magnets keep pulling me into the kitchen. That's why I can't lose weight. Anybody have that problem? You got to get those metal fillings out of your teeth. All right, now here's the amazing thing. Even low levels can cause trouble. Tufts University professor Sheldon Krinsky in Hormonal Chaos showed that even levels considered acceptable by the EPA interfere with normal hormone balance. Sex hormones, early puberty in girls with estrogen imbalances, testosterone, cortisol, all the adrenal and endocrine imbalances. Now, what you need to know is, for the vast majority of people, like I said, our genes have adapted very well. And I would say, I don't know the exact percentage, but for the overwhelming majority, we can detoxify most things pretty well. But there is a small percent of the population, somewhere between 5 to 20%, that is very, very sensitive to these chemical toxicities. It shows up for these people as multiple chemical sensitivity disorder. Any fumes, any perfumes, any gasoline fumes can create severe reactions in these people, and we'll show you why genetically that happens. Here's Carol found her own way of coping with the hot flashes. So we all, to a certain extent, have to find our own path out. Now, life can be toxic. This guy is having a beer with his buddy. He says, not only was I left holding the bag, it was full of toxic waste. And that's a bad day. Have another beer on me, okay? All right, so what's the key to a clean inner environment? Our liver. And there are two phases of detoxification that the liver goes through to protect us. So liver, of course, is right up here on the right side under your rib cage. That's why I put this picture up. It goes all the way to the left side there, but sits up pretty high. Phase 1 detox is where chemicals come in and they're basically oxidized. They are prepared to be to enter into phase 2, where they can be sent out of the body. But first, toxins that our body encounters must be turned into what we call a toxic intermediate. And then that toxic intermediate goes into phase 2, where it's flushed out the body. So phase 2 packages up the toxins. The process is called conjugation, and it shifts them out the kidneys, bile, and stool. Phase 1 all occurs in what we call cytochrome P450 enzymes. Enzymes, I'll teach you a lot about enzymes and proteins tonight, but enzymes are all proteins. They're amino acids strung together in three-dimensional configurations that create activity in the body. Enzymes drive our functions, every chemical function that happens in our body to create energy, to create life, to sustain life, involves enzymes. And so these enzymes in the liver help move these toxins from fat-soluble into water-soluble, which then can go out in the urine and the stool. Here's a little better picture of the biochemistry. You see that in phase 1, fat-soluble toxins enter these cytochrome P450 enzymes. They create these intermediate metabolites which actually in most cases are more toxic than the toxin that they just oxidized or reduced. So this is a big problem, and I'll show you why in a minute. These intermediate metabolites are very, very toxic. Now, in normal circumstances, they go to phase 2, where they're conjugated by these different chemicals, sulfur, glucuronidation, glutathione. We'll learn more about glutathione in a minute. And they become water-soluble and can be eliminated. So what happens if you have an enzymatic defect that creates an overactive phase 1 enzymes? Well, you may turn just sort of basic toxins into very bad toxic intermediates. And if your phase 2 enzymes aren't working well, you may have a gene that lowers the ability of them to conjugate, and what happens is you've created now a worse situation, and these toxic intermediates then just destroy mitochondria, destroy energy, destroy cells, and create disease. And then you see all the nutrients that are needed to support phase 1 and phase 2. The biochemistry of detoxification is very complex. This is a nice simple diagram, but this stuff's incredibly complex, so the fact that we know as much as we do is amazing. This is sort of the overarching concept. Our genetic structure interacts with our environment and our individual choices to create the risk for disease. I like this because you'll see a lot of people say, oh, it's just genes and environment. We're born with genes, and if we hit the wrong environment or we get exposed to the wrong toxins, there's disease. And that's true. In some cases, just these two can create disease, but it's really important to remember we have a choice about a lot of this. We have a choice whether we expose ourselves or whether we learn enough to learn whether we're exposing ourselves or not. People, you know, like you guys come to these lectures and you learn information, and I know you go home and use it because I get emails the next day. Hey, should I be doing this? Hey, should I take that? Should I stop doing this? So that's good. This is where individual choice makes a difference. Let me talk briefly about what we call SNPs. These are single nucleotide polymorphisms. The reason they're so important, you look here, here's the double helix DNA that Watson and Crick, you know, sort of unraveled the mystery of. And you see there are these, what we call bases. There are little base pairs. A always goes with T, C always goes with G. And what you see, here's a normal sequence of DNA. And this could be, you know, this is just a single chromosome this is one chromosome, a part of one chromosome. So you look here and you see, here's a normal sequence. And what's a single nucleotide polymorphism? It's where one base pair is altered. So you see here, this is the same here as here, this is the same, this is the same, this is the same. Uh-oh, look here, this is GC, this is TA, and the rest are all the same. So I'm going to show you, if you have an altered nucleotide pair from one parent, that is called a heterozygous SNP. It only comes from one. If you have it from both, it's called a homozygous SNP. It means that it's on both chromosomes, and we'll talk about that more later. But a phase 1 SNP, if you have a SNP, an alteration in the DNA, and it will make more sense in a little, that changes the proteins that your body makes, the enzymes, in phase 1, those altered proteins can create either an increased phase 1 detoxification, or it can decrease it. So remember, increasing it isn't always better. You think, oh, it's working better to get rid of toxins. But remember, it creates toxic intermediates that can be more damaging than the original. So you need both phases really balanced. But the point is that a SNP can either increase the activity of a protein, an enzyme, or decrease it. And that'll come into play here in a minute. Now, how do SNPs tie into protein production? In the DNA, and I apologize if it's, you just get the overall concept. I know this can be confusing, but basically you look at, here's the nucleotide pairs. Every 3 different nucleotides code for one amino acid. And this string of 5 amino acids here creates a protein. Okay? All proteins are a string of different amino acids. There's I can't remember the exact number, 21 amino acids in the body, and depending on how they're strung together, you get a certain different protein. So we look here, here's a nucleotide polymorphism. This A, instead of being A, is a G. So GCA codes for the amino acid alanine. But look here, even though there's a SNP here, GCG codes for the exact same amino acid. So not every SNP creates an altered protein. In this case, even though there's a variation here, a SNP, a variation, wherever I say SNP, just think variation. There's a variation here, but it codes for the exact same amino acid. Now look here, if the G is a C and an, oh here, if this AGA codes for arginine, but look, here's a single nucleotide variation, but the AAA now codes for lysine. So now you have a completely different protein. And a single amino acid that's different in a protein may have a big change on the enzyme, or it may have a little one. But it can change it dramatically. Just one little nucleotide polymorphism, what we call a SNP. So remember that all enzymes are protein. They drive the metabolic reactions of the body, including the detoxification metabolism. SNPs create different forms of enzymes, remember, by altering a single amino acid in the protein. If there's no SNP or variation, that means you have a normal protein has 100% enzyme activity. In most cases, let's look at the situation where a variation will cause a decrease in the function. If you have what we call a heterozygous SNP, in other words, the variant comes from only one parent, that protein may end up having only 60% of the activity of the 100% that it should have. However, if you have a homozygous SNP, both parents, gave you this altered nucleotide that changed the protein structure, that protein may only function at 20%. So you can see how toxins can start to back up. If you have an enzyme working at 20% effectiveness, just think of you trying to do a job around the house. Well, homozygous would be like I tie one hand behind your back. If you've got a heterozygous SNP and I tie both hands behind your back, it's hard to get things done. It's going to take a lot longer, or there's some things you just can't do. So now the thing to remember is some SNPs increase the activity. So the SNP may not be one that decreases. It may create 120% activity, and the homozygous may create 150% activity. But the point is it alters its function. Now I'm going to tell you about a case study of one of my patients here in this practice, patient DM. She's 45 years old. She developed breast cancer a year ago, and she presented to me when she was done with all the chemo. I hadn't seen her in years. She came back into the practice about 3 or 4 months ago for a general exam. She finished her radiation, her chemo. She just wanted to, make sure she was healthy, that we got a fresh start. So what I did was a functional medicine test called Nutrival by Genova Diagnostics. This is a very intensive test. It's about an $1,800 test. Some insurances pay some of it, some don't. But it gives a very comprehensive look at all those functional markers we talked about. When I did that test on her, we detected that she had mercury toxicity. So at that point I said, listen, let's go ahead and get the genetics testing, because I want to know exactly what's going on in your genes that may or may not be causing a problem. So then we did this, what's called a detoxigenomics, and sure enough, it showed in the phase 1 enzymes, remember there's 2 phases in the liver, she had an increase in this particular cytochrome P450 enzyme called 1B1 that increases what we call 4-hydroxylation. It puts an oxygen and a hydrogen molecule onto the estrogen, and it creates a very cancerous estrogen metabolite. Okay? So we found in that phase 1 SNP increases the activity of that enzyme. So here's a case where the variation increases it. So she was taking normal estrogen and producing way too much of this toxic intermediate, which is carcinogenic, which causes cancer. Now, to make matters even worse, remember, because now that toxic intermediate has to go to the phase 2, and then maybe it can be detoxified. But she had 2 very significant defects or variations in her phase 2 enzyme genetics. One is this something called COMT, or the COMT gene. This helps to detoxify the toxic estrogen molecule. She had a homozygous SNP, a homozygous variation. She got it from both parents, and it decreases the activity dramatically. So now we've got a situation, you can see she's creating way too much carcinogenic, cancer-forming estrogen, and she has about 20% of the ability of you and I to get rid of that. So it's a real mess. Not only that, but she was missing what we call a glutathione transferase gene, and I'll show you these in a minute. Glutathione is an antioxidant, and it's a molecule made of 3 amino acids that attaches to toxic compounds and helps conjugate them and get them out of the body. So not only was she missing this COMT enzyme, but her glutathione transferase enzyme was missing as well. So here's an actual printout of her results. You see, when we do this testing, it gives us phase 1 detoxification. It looks at 1, 2, 3, 4, 5, 6, 7, 8 different cytochrome P450 genes. And you see the only one, the check mark means it's normal. The only one where she was abnormal was this 1B1. And what does that do? The 4-hydroxylation of estrogen. Okay? This is where the genetic toss of the dice is important. But what we're going to learn is the great thing about testing our genes now, the SNPs or variations that we test for today all have workarounds. So we have ways we can now work around these defects now that we know they exist to help her detoxify in other ways, and I'm going to show you that. So now this kind of lays out, here's the estrogens. Estradiol goes back and forth with estrone, which is E1. Now, normally we want estradiol to be broken down by this 1A1 cytochrome enzyme into a 2-hydroxyestrogen, which then, with the COMT, phase 2 here, becomes a protected, it actually protects you from breast cancer. Okay? Look what she does. She goes down this 1B1 pathway to 4-hydroxyestrogen, pro-carcinogenic, pro-cancer forming. Now, that's phase 1 here. These are the phase 1 enzymes. These are the phase 2. Look, she's got the homozygous SNP here. She can't metabolize this into its neutral form to get rid of it. So this just builds up to super toxic levels, and that's how she ended up with breast cancer. Not only that, but, you know, a year after finishing her chemo and she went for her yearly mammogram, they found some precancerous changes already in the other breast. So they did remove those, but you can see this is a serious problem. Now, to make matters even worse, this 4-hydroxy could be converted into this 3,4-quinone down here, which is still carcinogenic. But look, that needs the glutathione to neutralize it, and she's missing that too. So this is just a mess. Now, we haven't even talked about the heavy metal toxicity yet. She has mercury toxicity, right? This is just the genetic problems with her estrogen metabolism. So we'll show you how we dealt with that. So here you get the picture of her phase 2 profile. Plus means it's one from each parent. Negative means it's normal, okay? So look at that. She's got the homozygous COMT on both chromosomes. She got one from her mom, one from her dad. She cannot methylate out this carcinogenic compound. She doesn't even have it to make this non-carcinogenic compound fully metabolized. I mean, she has it, but it's at such a slow rate that it's obviously, this is where, remember, we talked about total toxic load. Her total toxic load now has overdriven her body's ability to keep up. And when it does that, that's when cancer cells start to form, right? They can't control it. Yes?
So had she had genetic testing years earlier, she possibly could have prevented?
Yes. And that's our goal now, is to prevent the recurrence. By the way, I treat her mom, who's in her late 70s, who had breast cancer in her 40s or 50s, and she had a recurrence 3 years ago. So mom's getting tested now too. So there's also acetylation is another series of detoxification that phase 2 does, and she has one small variant here. But much more important is glutathione, because glutathione is very deeply involved in the heavy metals. Glutathione is the major heavy metal detoxifier. So there are 3 glutathione genes that we measure for. One is absent, the other has a homozygous variation, and the other has a heterozygous variation. So it just, you know, she got a bad toss of the dice. So what do we do? What have we done? Well, first, minimize exposure. We've got to get the heavy metal out. We'll talk more about mercury in a minute, and I'll show you how we do that. But her own glutathione isn't getting rid of the metal, so we give her something called DMPS, which is a chelator, which can suck heavy metals out of the skin, out of the tissues, and help them to get rid of. So we can give her things. But first, minimize exposure. She has one mercury amalgam left. That's creating continual toxicity in her because the vapors go up, they get absorbed, and like you might have mercury amalgams, but if you don't have these genes, hey, it's a low enough exposure that you'll be fine. This is why there's always so much controversy, and studies don't show this so well because, you know, for years the Dental Association said, oh, mercury's fine, nobody gets toxic, right? And it's true to a certain extent. The studies will show, hey, it doesn't really pan out. People seem to be fine. But they're testing everybody like they're the same. If you have these genes, phase 1, phase 2 SNPs that she has, you're in trouble. It makes a big difference. If you don't, you might be okay. So you see how important it is to individualize and personalize all these ideas because they don't apply to populations. They apply to individuals, and we need to really understand it. So we started her right away on Epsom salt baths because Epsom has sulfur. Sulfur is a detoxifier. Let me see if I can go back to our here. So you see here, in addition to glutathione, which conjugates out heavy metals and these toxic intermediates, sulfur can also do it. And sulfur doesn't depend on the glutathione transferase gene. In other words, the genetic abnormality she has is not in making enough glutathione, it's in taking that glutathione and transferring it to the toxic intermediate or to the mercury. So she can't transfer the glutathione to help it get rid of it, but if we load her up with sulfur, sulfur has a love affair with heavy metals and toxic elements, and it'll attach to them, and then that can go right out the urine because it's all, then that makes it water soluble. Methylation, this is that COMP defect, the methyl group CH3. This is why we give, remember we talked about homocysteine? That's a measure of a methylation problem. If the homocystine's high, we got to give high B6, high B12, high folic acid, maybe even some SAMe, which is S-adenosylmethionine, which gives a methyl group. So we can work around these defects. So sulfur is a key, and we go back to here. So Epsom salt baths, saunas, exercise, that helps to sweat out the toxins out of the skin. We certainly minimize our exposure, watch the heavy metals in tuna, swordfish, shark, bass, all the predator fish that eat the little ones that concentrate all this stuff down the line. Eat detoxifying food, cruciferous veggies. If there was one thing I would tell you, it's the broccoli, the cauliflower, the Brussels sprouts. These vegetables are full of sulfur, and sulfur is what pulls the toxins out of the body. Well, look at the old baths. You think back to the ancient sulfur baths, and, you know, I've visited places in Israel where there are sulfur baths, and you soak, remember the healing powers. This would have been those people with those very sort of, the small percent that have those really rare genes that they couldn't detoxify well. They go into here, and suddenly they can pull out enough toxins and heal. Certain nutrients and herbs. Oh, green tea, cilantro is a very deep detoxifier. It gets very deep in the tissues. Nutrients and herbs like glutathione. You can't really take glutathione, but remember we've talked to you about that little yellow pill, Protandim. That has milk thistle, green tea. That increases your glutathione levels by about 2 to 3 times in the cells. It helps them to produce more of your own glutathione. So there are lots of herbs that help our detoxification system. Certain supplements can do it as well. Here's the Protandim, taurine, glycine, certain amino acids that help detoxify. And then the medically supervised chelation agents, the DMPS, the DMSA, there's EDTA for lead. So these are the detox interventions that we take. Let's move on to the mercury portion of the situation. Are there any questions on that, or we okay? So we look at mercury. What does mercury cause in most people? Brain fog, depression, insomnia, memory deficit, slowed thinking, weight gain. Now the same mercury toxicity can cause many different diseases. Remember we talked about there's a biology of the disease. That's the biology, the biochemistry of how mercury interferes with the enzymes in the body. And then there's a biology of the individual. The biology of the disease interacts with the biology of the individual to create problems. So depending on your situation, mercury in some people may cause autism, ADHD, Alzheimer's, Parkinson's, depression, weight gain, the list goes on and on. The point being, it depends. We don't know. So you can see, you look at these disorders, if you just treat a disease, you're going to be in trouble. You have to see how that disease interacts with the individual. When your body can't detoxify mercury, it does tend to accumulate eventually in the brain. Worldwide, 6 million pounds of mercury emissions a year, mostly China, where without any environmental protection, you've got these coal-burning plants. When I grew up in Youngstown, probably in the steel cities, there were tons of coal-burning steel factories. I remember the smokestacks just spewing out the stuff. Symptoms of mercury toxicity. I don't know how to pronounce his name. Wozek in 2006 studied 465 patients with chronic mercury toxicity. 32% of them had severe fatigue, 88% memory loss, 30% depression. Now, it's much more common if you have certain other genes. We didn't talk about the ApoE4 gene, but that's another genetic variant that we don't test for in the test I did on the other patient, but we can test for it as well. The same company does the test, and that's associated with Alzheimer's and heart disease and an increased risk of mercury toxicity. And about 20% of the population has this gene. You'll see a lot of the new cardiovascular paradigms. A lot of doctors now are doing like carotid ultrasounds in the office, and they do genetic testing for this ApoE4 gene. And if you have it, we kind of alter the way we treat high cholesterol and other issues. I'll just briefly go over this case of George that Hyman talks about in his book Ultramind. Had dementia and could no longer manage business, withdrawn socially, could not function at home, was basically slipping away. Turns out he grew up in steel country where I did, Youngstown, Ohio, coal-burning plants exposed to very high mercury emissions. Well, when Dr. Hyman took a deep look into his genes, he had a bunch of problems, just like our last patient. The ApoE4 gene was present. So there was also the absent glutathione transferase gene that we just talked about that our other patient had. There's also this MTHFR defect. We haven't talked about that, but this is something called methylene tetrahydrofolate reductase. That's a mouthful, but what it means is your body lacks the enzyme that converts folic acid into 5-methyl tetrahydrofolate, which is the active form. You can give a person a bunch of folic acid, but if they don't have this enzyme, they cannot convert it into the active form. And remember, in our homocysteine pathway, it's that active form of MTHF that's necessary to metabolize the homocysteine into methionine, make the methyl group so you can detoxify. So you can see how this all ties together. And he also had a CETP gene, the cholesterol esterol transport that causes cholesterol to be super high. So the concept here is that George wasn't genetically programmed to have dementia, but he lived with a loaded gun for which a toxic environment pulled the trigger. So when we looked at George, he treated George very much like we treated our patient here. The heavy metals combined with all these genetic SNPs, variants, jammed up George's biochemistry, and anytime that happens, it leads to these two processes, oxidative stress and inflammation, which are the common pathways for virtually all cell death and cell demise, even in the mitochondria. You got to understand, we talked about taking the batteries dying in a flashlight, just like when the mitochondria go out, there's no light, the cell's gone, it's dead. The reason mitochondria are so vulnerable is because that's where basically the way we make ATP and energy is through oxidation. But there's also glutathione in the mitochondria that neutralizes the oxidative stress. It's like metabolic exhaust. But if you don't have that glutathione, your mitochondria are the first thing that go. It's the energy of the cell. The batteries dim, the lights start to go out, and boom, the house is empty. So heavy metals jam up that chemistry. The CETP gene and the ApoE together dramatically increase the risk of dementia. And we work around our genes just like we did with our last patient by making healthy choices, dietary changes, chelating agents, environmental changes, avoiding chronic exposure. So you look at, I mean, the challenges of dealing with heavy metals are like the challenge of this sun. You see, the challenges of raising a son. Well, as a matter of fact, the sun says, the world does revolve around me. This is so common to the youth of every era, right? Okay, this is just a chart of some of the main genes to kind of summarize in dementia and brain health. The MTHFR gene, which controls methylation, and we improve it. We work around it by giving high doses of folic acid to drive the reaction, or you can they now manufacture the active form, and that's what I've gone to in a lot of patients that have this. The ApoE4 gene carries cholesterol and heavy metals, so you need to choose whole foods and really watch the glycemic load, the sugar load in your diet. The glutathione transferase gene helps your body to detoxify. How do we work around it? We give plenty of amino acids, N-acetylcysteine. This is where Protandim would come in. Eat 2 cups of cruciferous vegetables a day to get plenty of workaround. So if you're missing this transferase gene, you can work around it. And that's your answer to this last patient. Had we done this testing on her 20 years ago, and she'd been eating 2 cups of broccoli or taking, there are actually extracts now of cauliflower and broccoli you can take called indole-3-carbinol, which gives you the active ingredient that, you know, it's not the same as eating the whole food, but it can help a lot. So all these things may have prevented, yes. So our goal is now to prevent a recurrence. The CETP gene can be worked around again through whole foods and a low glycemic diet. This COMP gene, catechol methyltransferase, which helps metabolize hormones, we learned, and neurotransmitters. You've got to make sure you got plenty of the B6, B12, folic acid, and that trimethylglycine. And then this SOD gene, which is superoxide dismutase. This, remember, that little yellow pill Protandim, Dr. McCord, he's the one that discovered this superoxide dismutase. So he basically is the guy who discovered SOD and then developed this Protandim to help boost its level. Okay, so we work around our genes. So again, chelating agents, we talked about removing the exposure, detoxifying foods, Epsom salts, lower the cholesterol, lower the homocysteine. It will probably take a year to get the heavy metals out of this patient. It takes a year or two. It's a very slow process. We use some creams, that DMPS cream. You put it on every night for a week, then you take a week off, then you put it on again, then you take it off. You got to replenish a lot of nutrients because the chelating agents not only take the bad stuff out, they sometimes chelate good minerals out. So you have to be on pretty high doses of vitamins while you're chelating out. So let's talk last about Parkinson's, because this is something everybody worries about. It's a big deal. You see Muhammad Ali here, Michael J. Fox, over 1 million Americans. It's $23 billion a year, second only to Alzheimer's in terms of, disability and cost. Here's the amazing thing. Most people don't know this. A study of 193 identical twins found genetics do not play a major role in Parkinson's. In fact, we've known for over 30 years. A 1979 report revealed that drug addicts who consumed heroin tainted with the toxin mdPersonal developed Parkinson's. Parkinson's is a toxic reaction. It's a detoxification disease, basically. Exposure to toxins from any source puts you at risk. Pesticides, farms, contaminated well water, industrial plants, printing plants. Toxins must be excreted through the liver's detox system. Again, there's certain genes. We didn't test for this one, but the 2D6 gene is linked to Parkinson's, and that gene is slow in 5 to 10% of Caucasians. So there's a slow form and maybe a fast form, but oh no, that's the gene. Oh, sorry. Yeah, let me explain that. That's a great question. There's genetics that create diseases like Huntington's chorea or that's different. Yeah, this is the gene that detoxifies. This is a detoxification gene. So the genetics of this is that it doesn't create the disease like a mother and father had it, like the kid will have it. It's just that your body gets that variation that doesn't allow it to detoxify. That's still a genetic variation, but it's not one that's passed on through the traditional, like, this is a disease that, my mother had, my father had, and I'm going to have. It predisposes you to toxicity, not to the disease, right? Yeah, certain diseases that are genetic, like some of the ALS or things like that. Yeah, those I'm pretty sure ALS is genetically, or Huntington's chorea for sure. That is passed on by the genes. You pretty much know if one parent had it, you're going to get the gene, or sickle cell or whatever. Okay, that's a better example. So what is this strategy? Dr. Jeffrey Cummings says we need to adopt this strategy of neuroprotection. Basically, professor of neurology and psychiatry at UCLA says we must focus on prevention and detox as careful and deliberate strategies. Symptom management, he says, must give way to identification of environmental hazards that can be eliminated and chemopreventive strategies. This is from JAMA 1999 when he kind of wrote up this letter, and this is a really amazing thing. He says the therapeutic nihilism traditionally implied in the term degenerative, because we say, oh, there's a degenerative disease, there's nothing you can do about it. And he's saying that's kind of just a poor excuse for giving up, right? That's the therapeutic nihilism. Traditionally implied in the term degenerative is giving way to the dissection of the sequence of the molecular events that lead from the initial trigger to cellular destruction. Basically, this is another good definition of functional medicine. That's what we're doing. We're looking at the triggers, the molecular events. That's what that NutriVal testing does. The functional markers, those are looking at the molecular events, how well your cells function at the molecular level. So here's the cartoon, the one guy saying to the other, yeah, I forgot to make a backup copy of my brain, so everything I learned last semester was lost. How about last night? Okay, so here's some guys working on the brain, neuroprotection in Parkinson's disease. Environmental factors interact with susceptible genes. This is what we're talking about, detoxification genes, to trigger brain injury. Remember, it all happens at inflammation and oxidative stress. So toxins themselves can cause oxidative stress, and toxins can cause inflammation. And inflammation leads to oxidative stress leads to inflammation, etc. The excitation of the cells then leads to cell death, usually first in the mitochondria, and then the cell just gives out, and then the development of mood or brain disorders and behavior problems. So the author suggests if we use antioxidants to lower oxidative stress, if we use energy boosters and anti-inflammatory treatments, fish oils, etc., and compounds that reduce excitotoxicity of the brain, we can protect it and prevent and stop and reverse this process. So we know, for example, changes in brain function on PET scan can be seen in Parkinson's disease actually decades before the disease is diagnosed. By the time of diagnosis, greater than 60% of those neurons related to movement in the substantia nigra are degenerated or missing or gone. Those are the neurons that die because the mitochondria give out from the toxicity, and they can no longer produce dopamine. That's why L-DOPA, we give that compound to Parkinson's patients to help bring them back. Again, we talked about the importance of detoxification, and the choices we make becomes even more apparent now. And you're right, Madeline. I mean, the choice to have that test is a choice, right? So, and being here to even know it exists is another choice. So this is the kind of thing that helps us make good decisions. A little bit about Dr. Joe McCord, the discoverer of SOD and the protandum. It really, the little yellow pill here is what we call a NRF2 activator. It actually, when you eat the protandum pill, it goes to the bloodstream, it goes outside the cell, it gets into the cell, it triggers activation of something called NRF2, which then goes into the nucleus of the cell and triggers the DNA to produce more glutathione, to produce more superoxide dismutase. And all protandum is a combination of 5 herbs: green tea, milk thistle, ashwagandha, bacopa, and something else I can't remember. The point is, he worked for 15, 20 years to find out just the right combination of these ingredients that maximize the ability of the body. So they actually got something like a 12 to 13 times increase in the production of SOD, superoxide dismutase, and glutathione over taking any of these herbs individually. So there's a certain synergy that he spent years in the laboratory, and now multiple research centers are actually just using protandum as the model for decreasing oxidative stress in their experiments. So we're seeing more and more experiments come out to show. So a nice simple way, really, at about I don't know, the stuff costs $1.25 a day to improve your detoxification ability is something like protandum without trying to buy a million different supplements. That's pretty much it. I don't think we'll... Here's a final cartoon, the lighter side of toxicity. The dog here is sick, and the vet says, I know this... the guy's got all these chains and heavy metals. He goes, I know how this must sound, but your dog is suffering from heavy metal toxicity. So anyway, that's it. Interesting, huh? Any questions or... No, I have to say, it's remarkable. And I told Alice before the talks, 6 months ago, before I really got into function, you'd hear about these. I had no idea that you could do these things and figure it out. And believe me, most people don't. There's only about 2,000 functional medicine doctors in the country. It's probably increasing maybe by a thousand or two a year. But, out of 700, 800,000 doctors, it's not many. So it's very important. I actually have a patient now who are waiting on some results. He came to me. He's young. He's in his late 40s. They've diagnosed him with Parkinson's. He's actually, I sent him for a second opinion, and yeah, they say that's. And what do they say to do? Well, you can try the medicine, or we can just follow you, and when symptoms get bad, then we'll, But nobody is looking for the cause, right? It's just, that's the therapeutic nihilism. It just says, yeah, gee, you got it. too bad. Well, let's just wait till you're really bad. That drives me nuts. And it's true. Maybe we won't be able to help him. But there's a great likelihood, because you've seen when we do the detoxification genetics, when we measure all his metabolic markers, we're going to find something that we can work on, and especially knowing that Parkinson's is often toxicity. So this is a whole new paradigm, and you see how if you get stuck on naming a disease, they've just given up by default. And so it drives me nuts. So anyway, thank you all for coming.